everybody. Today we're going to be looking at inversions of intervals, and the reason I'm showing you this is because later on down the road we're going to come up against music that's called invertible counterpoint, and I just want you to know a little bit about it so that when we get there you're not completely in the dark. And it'll come up again when we discuss very unusual intervals called tritones. So if you look at the first example, we have an E to an F, which is a second, but what happens if we take the E and we move it up an octave so that it's now above the F? What kind of interval do we get? And this is called an inversion. So this interval is an inversion of this interval. We're not exactly flipping it upside down, but we're just taking the bottom note and then putting it on the top so that that second higher note is now the bottom note. So you can see that a second turns into a seventh. And then a third, same thing, if we bring this E up and put it on top of the G, that becomes a sixth. And then here's a fourth, and we bring the E up above the A, and that becomes a fifth. And then we have a fifth here, we bring the E up. The E is now above the B, and we have a fifth becoming a fourth. And now we have a sixth, an EC. We bring the E up above the C, and we get a third. And now we have a seventh, E to D. We bring the E up above the D, and a seventh becomes a second. And here's the question: do you see a pattern evolving here? Some kind of numerical or even algebraic pattern, or a pattern that you could describe even algebraically? And the answer is yes. The sum of each of these integers, 2 plus 7 is 9, 3 plus 6 is 9, they all add up to 9. So without using an algebraic equation, we can intuitively see that since they all add up to 9, if I'm given, for instance, a fourth and asked what is the inversion of a fourth, it would be 9 minus 4 equals 5. What's the inversion of a sixth? Well, it would be 9 minus 6 equals 3, etc. And that's how that works. And let's see if the same thing holds true if we go in reverse now. So we'll start with the seventh, and we're going to bring the E down below the F, and yeah, it becomes a second. The sixth becomes a third. E is coming down. I'm not going to draw it for each one now. The fifth becomes a fourth. The fourth becomes a fifth. The third becomes a sixth, and a second becomes a seventh. And let's see what happens if we add qualities to these intervals. For example, we have a minor second, which becomes a major seventh. And we have a minor third that becomes a major sixth. And we have a perfect fourth that becomes a perfect fifth. A perfect fifth becomes a perfect fourth. A minor sixth becomes a major third. And a minor seventh becomes a major second. So it looks like minors become major and perfects remain perfect. All right, let's look at the next line. Now we're beginning with a major seventh, and it becomes a minor second. Major sixth becomes a minor third. Perfect fifth becomes a perfect fourth. Perfect fourth inverts to a perfect fifth. A major third inverts to a minor sixth, and a major second inverts to a minor seventh. And looking at this line, major intervals invert to minor intervals. Perfect intervals invert to perfect intervals. So, summing up both of these lines, we found out that minor intervals invert to major, major intervals invert to minor, and perfect intervals invert to perfect intervals. And let's see what happens with augmented and diminished intervals. Here we have a D flat to an E, so that's an augmented second. It inverts to a diminished seventh. Here we have an augmented third, D flat to F sharp, that inverts to a diminished sixth. And here we have an augmented fourth that inverts to a diminished fifth. Next one is an augmented fifth that inverts to a diminished fourth. The next, D flat to B, is an augmented sixth, and that inverts to a diminished third. And the final one is an augmented seventh, which inverts to a diminished second. And let's take a look at the reverse. We begin with a diminished seventh. I bring that D flat down an octave below the E, and I get my augmented second. And then a diminished sixth becomes an augmented third, diminished fifth, G to D flat comes down, becomes an augmented fourth. So this is a D flat down here. So continuing on, I have my diminished fourth here, which inverts to an augmented fifth. I have a diminished third, inverts to an augmented sixth, and I have a diminished second, inverting to an augmented seventh. So looking at these bottom two lines, we've learned that the integers representing the intervals still add up to 9, 2 and 7, 3 and 6, 4 and 5, 5 and 4, etc. And we've also learned that augmented intervals, when inverted, become diminished, and diminished intervals, when inverted, become augmented.